So this is page 304, number 16, and we're asked to graph these 12 different functions that are given here. And we could do each of these using a table of values and go through and find a whole bunch of points. But the key here to notice is using the habit of mind chunking to help you make these graphs. So for the first one, we're trying to graph y equals the quantity x plus 3 squared. And I'm going to start by considering the graph of y equals x squared, our basic graph. And you know that goes through the point 0, 0, 1, 1, and negative 1, 1, 2, 4, and negative 2, 4. It has sort of that U shape like this. Okay. Well then, if we consider the graph of y equals x plus 3 squared, the one that was given in this problem, all of a sudden we need a value 3 less than x to get the same y value after we square it. For example, if we plugged in negative 3 for x, we would do negative 3 plus 3, which is 0, and 0 squared would be 0. So to get a y value of 0, we need to plug in negative 3. To get a y value of 1, we would need to plug in either negative 4, so that inside the parentheses we have negative 1, and we square it and we get 1, or negative 2, so that inside the parentheses we would get 1 and square it and have 1. To get a value of 4, we need inside the parentheses to be 2, which we can plug in negative 5, and we get 4, or negative 1 and get 4. And our graph ends up looking like this. And what happened was the graph slid 3 units to the left, which, looking at the equation, makes sense because we now need a value of x that is 3 less than what we had before. So the same thing is going to happen for the next one. Our basic function, y equals x cubed, looks something like this. And if we plug in values that are 3 less for x, now we get a value that we're trying to graph that looks something like that. So the green graph is our basic function, y equals x cubed. And then the red one is the one that we're trying to graph. So for the next one, we know what y equals absolute value of x looks like. The graph that we're trying to do is the same graph. We just slide it to the left 3. And for the next one, we have square root of x, so plugging in negative 3 gives us a y value of 0. Plugging in negative 2 gives a y value of 1. Plugging in 1 gives a y value of 2 because we get the square root of 4, which is 2. So there's our basic function, which is shifted to the left 3. For next one, y minus 6 equals x squared. So I'm going to graph y equals x squared again here. So this is y equals x squared. And now, to get the same value of x that we had before, we now need a y value that's 6 greater. So for example, we'd have to plug 6 in for y to get 0 for x. So that point is up here, and we would need to plug in 7 for y to get 1 or negative 1 for x. So those values are up here, and I don't have much room for this. I probably should have shifted my axes down. But this graph of y minus 6 equals x squared is our basic function, y equals x squared, shifted 6 units up. Likewise, for the next one, it's our basic function, y equals x cubed, shifted 6 units up. And 2. We're going to have our absolute value functions shifted 6 units up, and our square root function shifted 6 units up. And then we get to one where our basic function again is y equals x squared, so I'll draw that in green. And our new function now, we need a y value that's 6 greater and an x value that is 3 less. So we can move it up 6 and to the left 3. This one's not going to have very much room either. And for our final 4, up 6 and 3 left. So there's our basic graph y equals x cubed. It got moved to the left 3 and up 6. Here's our basic function, y equals absolute value of x. And here is our function, y equals square root of x. It got moved 3 to the left and up 6. So the final part of this question asks, how are the graphs in parts A through L related to the basic graphs? So parts A through D are the basic graphs. Translated 3 to the left. Okay, you can use the fancy math word translated here or the word slide. So the basic graphs slid 3 units to the left. Parts E through H are the basic graphs. Slid up 6. And then parts I through L are the basic graphs. Translated 3 to the left and up 6. The key to this problem is really looking at these equations and seeing the structure of the basic functions there with this putting a blob around or your thumb over these y minus 6's and the x plus 3's and thinking about them as, okay, what value of x do I need to make this look like the basic function?